dinner.
Great.
And we're on!
Excellent.
Hey, cheers, David!
Cheers.
Congratulations, by the way, on the Pioneer Award and
Thank you
the
very
Audience
much.
Choice. Yes.
The audience choice that was a real surprise.
That was yes.
And thank you to everyone for voting for it.
Yes. Well deserved, I think, on many levels.
You're very, very kind.
But
Pour my beer out.
yes, pour your beer out. This is a blighty. We were talking about catastrophes
We were. And
killer asteroids.
an asteroid day.
Yes, this man really knows his catastrophe theory, killer asteroids, astronomy. It's his whole side of David. I just didn't really.
Well, I've always, it's interesting, intuitively, people don't really rate the risk of death on asteroids. It's somewhere between the equivalent of plane crash rate to a road accident. And different theories suggest different ends of that spectrum. The thing is, it's either horrendous or terribly horrendous.
Well, when it happens, it's
And no one knows anyone who's died because the statistics suggest we all die together.
Yes. By definition, if you're all blind, then nobody knows.
That's right, so it's pretty bad. But anyway, the issue comes, how many asteroids are really out there? And
We know there's at least 600,000 because I've counted at least that many.
But I think one of the problems with that is because way back in Frontier, I love the astronomy thing.
Yeah.
The whole astronomy thing with Frontier, to me, kept me sane during Frontier, which is 5 years of work. And so that was really done for me. But talking to really nice guys at the astronomy department in Cambridge. If you draw a graph of the instance of various bodies in the solar system, you get a wonderful inverse exponential.
Yeah.
In other words, there's an uncountable amount of tiny dust.
It's a question of what the power law actually is,
That's
right?
But we have pretty good idea what it is.
Yeah.
Going all the way down to when it gets very bumpy because we don't have too many data points where the planets are.
Yeah.
And what's fascinating is that does give us an idea of how many asteroids there are. And it matches the numbers we can see. It's up quite a bit because we can't see quite obviously.
Yeah.
But there is a whole other population. And those are the asteroids that aren't gravitationally bound to the solar system.
The comets is what we would say. We
Well,
call them
comets.
comets because they tend to be icy because they've been in
Absolutely.
deep space and they produce tails.
And one of the things that came out of the making of Elite Dangerous is we've said, well, yes, we've got 160,000 real systems, all that stuff, blah, blah, blah.
Yeah.
But the night sky didn't match our night sky when we draw it from first principles.
Yeah.
It was too uniform and too bright. So we had to add a lot of dust. What's interesting is that dust was predominantly in the galactic plane, much more so than stars. Now, I don't really know why that is, but I'm sure there are people cleverer than me who have good ideas why it is. I suspect it's to do with electromagnetic effects and gaseous effects, where the momentum is very quickly lost. But anyway, the point really is with that. And before we went on camera, Scott
Yes,
and I were talking.
we had all sorts of theories. This guy is great.
We both have come at it from slightly different directions. So there's a number between 23 and 22 million years, which is the periodicity of major events, asteroidal impacts or cometary impacts on the Earth.
But we see them as extinction events.
Yeah, these are big.
Yes,
These are big
lots
things.
of things dying out, crazy stuff happening in the ecosystem. Bombardment events. Yeah.
And there's a peak on this timescale, which exactly matches, spookily or not, where the period that the sun passes through the galactic plane.
Yeah.
Which is where all this dust is.
Yeah.
And the thing that is, to be honest, quite terrifying is that population of bodies. I mean, when I say dust, that will include everything from things that we would recognise as dust, really tiny, sort of all the way up through gravel, to things that are as big as a bus.
Yes.
And maybe higher, which each of those would have a real impact. Because one of the problems that I think people don't really appreciate, they see the galaxy as being relatively stopped, but most objects are moving at relative speeds, measured in tens of kilometres a second, which in galactic scale is very, very slow. But in energy scale is actually really big.
3 kilometers per second is the same as a kilo of TNT, and you square it for every time you relative to that.
And these bodies that aren't gravitationally bound to the sun, it can quite easily be in hundreds of kilometers a second relative speed.
Yeah.
So they are really dangerous, and we don't the worry with these things, which are in what's often called hyperbolic orbits rather than round orbits, is we can't track them because they will only come through our system once, typically. Or once in 20 million years, which is effectively once. So we don't have an idea, really, of how big that flux is, other than by using statistical methods based on other pieces of information. Now, there's another good thing, which is, this goes back to the frontier days, when if you draw a graph that I was saying earlier about the presence of bodies of low mass, you then look at the galaxy and draw a graph of the populations of stars. It's a remarkably similar graph with a remarkably similar scale.
And you know that down at the low end, there's a lot of small objects.
That's right. And that's why in Frontier I put in a lot of brown dwarfs.
Yes, and I keep getting them when I'm trying to refuel, and I can't refuel off a brown dwarf.
But in Frontier, the theory was there are no brown dwarfs.
Right, that was the original. Well, brown dwarfs hadn't really even come into a major. They hadn't really been observed at that point when Frontier was made.
But no, indeed, and there was a lot to suggest. People were suggesting that it was to do with that planets form differently to stars. And I think that opinion has gradually changed over the years. Which is great. But I believe you should be able to join the dots. And if you do that, there is a vast flux of planetary-sized objects that are orphaned. But they're very, very cold, and it will be extremely hard to see them.
Right, and the smaller they are, the colder they get, because brown dwarfs emit heat because they're still collapsing. But even smaller ones, they don't do so, let's say, right?
I mean, we're talking potentially Jupiter-sized objects. But they're profoundly cold. And also, on a stellar terms, the density isn't that high. But there is a huge, or potentially a huge number of these things. Now, various theories suggest, and there are good reasons for it, that there aren't too many of them, just because of the way they get captured. But other theories suggest they also get expelled by close encounters as well.
Right.
Now, one of the things that we were arguing about, and neither is, I think, to be fair, there isn't enough information.
Yes, we are definitely dealing with a dearth of information here, and that's half the fun, right?
That's right, and it's always good. But looking, the galaxy is, if you think of it as the planets are all flying through or the stars are all flying through a snowstorm of other stars, and the sun is no different with that. And so a lot of the nearby stars have relative motions, actually meaning they're approaching us. Others have relative motions, mean they're receding. And so quite a few. With Frontier, I had an ambition to...
This is the original Frontier. 1990, there about, right? 1993, right?
And I actually did, the Galaxy was done in about 1988, 1989.
Wow.
And so I got all the information I could, including talking to the astronomy department and that sort of thing. And I got information for a lot of the nearby systems and their relative motions. And what amazed me is I started thinking, where will they be in the year 3200? And as you do. And they had moved a little bit, but part of me couldn't help extrapolating.
Oh, yes.
Especially when it points towards the sun. And I thought,
oh dear, it's coming straight for us!
And there were a number that within a period of a number of tens of thousands of years, and that I do mean that, I don't mean millions of years. A number we're going to pass quite close to the sun. And there was one, I think it's AC plus 39 3888 or something, which amazingly romantic name. I'm sure it's got a better name than that. Was going to pass. And the figure I came out with several different figures depending on which figure you use for the sidereal motion.
Because error bars in astronomy are very big.
That's right.
We love our error bars in astronomy.
But I've got a horrible feeling it's something like 0.5 of a light year plus minus 0.8, which...
And that is not atypical of good astronomy, right?
But I know those are silly error bars, but the thing that alarmed me is that includes 0.
Yes,
and there was. I was a huge fan of science fiction when I was a kid, and I remember
I'm
reading.
Sure you still are, right?
I still am. Yeah.
Yes.
I don't have the time I had then to read, but Lucifer's Hammer was a lovely
one of
book.
my favorites.
That's right. Larry Niven and Jerry Pournelle, lovely book.
Love those guys.
Anyway, it starts off with. I'm trying to remember, an astronomer and a kid, was it? Seeing a star.
Yeah.
They get to name this comet coming in.
Yes.
And it gets bigger and bigger, and people say, wow, it's going to be spectacular. They're all getting
It's
excited.
going to be really spectacular.
Yeah. And then they start mentioning the error bars. And at each point, the error bars narrow, but still include the Earth.
Yes. Well, that's yeah.
I mean, the title of the book probably gives it away a bit.
Yes, I just.
But it's a good book. Read it. And it's also about the aftermath, but clearly it hits.
Right. But actually, I mean, that's the funny thing. I always like to explain. Every now and then, you'll see a headline in the newspaper, or not a headline, but you'll see some like site saying, "Such and such an asteroid has a chance of hitting the Earth."
Oh yes, that's right.
And then the chance will go down. The chance will get shorter and shorter, and then it'll go to zero. So it'll be like 1,000 to 1, 100 to 1, 10 to 1, and 0. How does that happen? That's because your ellipse is going down, and suddenly the Earth is out here, and it drops out of the error ellipse.
And I thought Lucifer's Hammer did that quite well, actually.
Yeah.
I enjoyed it. I mean, but I think the point though is with error bars is, to be honest, it's still going to be concentrated towards the centre of the error bar.
There's still quite a good chance of stars coming pretty close to the Sun and the Oort cloud specifically.
That's right. And by the way, I'm not being a doom merchant because we've got much better figures now, and it's much further away now.
Yes, thankfully.
Because
We
the
have
error
really
bars-
good charts on this with the exact distances.
And the error bars are much narrowed, but back in 88, 99 when I was doing it, they, or at least it might have been my maths as well.
I'll say it's the data. I'm going to be a good guest or whatever, right?
Yeah. Anyway, the point is, I thought, wow, I was quite. It's funny. It's like in Lucifer's Hammer. You sort of get excited by it, and then you think, oh, wait a second.
Wait, yes.
But the number I vaguely remember was something like 30,000 years. It was
Right.
But what shocked me is I was expecting it to be tens of millions of years. Because even then, my perception was that galactic things happen in millions of years, and thousands of years are essentially like a nanosecond. It's a
Right, yeah. Now,
tiny,
30,000 years, nothing on the
That's right.
galactic scale, right?
So that was interesting, and I think there were 4 or 5 of the probably less than 100 that I looked at that were coming really quite close. So I decided to leave it in their star positions. But it did get me thinking about this whole asteroid day and risk. Because potentially, these are the objects we can see. Stars are really, really bright. You can't miss them. If it is the case that there are an awful lot of dark objects that you can only see when they're really near, it's a bit like driving through a snowstorm. You don't see the snow until they catch in your headlights.
Yes.
And so there may well be, Jupiter-sized objects, Earth-sized objects out there that could pass through our solar system. Now, the other thing that people will have seen playing games like Elite Dangerous is, fortunately, the planets are such tiny, tiny specks. The chances of anything hitting are remarkably small. But the biggest danger is if one of these things plows through the Oort cloud.
Yeah.
It basically randomizes the orbits of just about everything.
And a bunch of them will come down and say hello to the Sun.
That's right.
And by definition, they'll pass the Earth, right?
Absolutely. And then, so looking at this extinction period we're talking about, there are a lot of other semi-random things that we don't really know. And that's how you get from the bottom end, or towards the bottom end, which is of the order of an airline disaster.
Yes.
Which, to be honest, is very low.
Airline travel is very, very safe. We've got to say that.
But the other end of the spectrum is road accidents. I mean, people I know lots of people who get terrified about flying.
Yes.
You are so much more likely to die on the way to or from the airport in your car.
It's a control thing, really. People don't like not being in control.
That's right. And if you just stand at any airport around the world, you see planes taking off once a minute, once every 30 seconds.
I will point out a plane did drive off the runway in Boston today.
I know, I saw that. However...
But that's a rare event.
No one was hurt.
No one was
hurt.
hurt.
I understand, other than the plane.
As far as I can tell, yes.
But and actually, some people from Frontier are actually in Boston as we speak.
Oh, great!
So for the first
for
time...
PAX East, I guess?
That's right, absolutely. So I'm not going to PAX East, I'm afraid. Because the two overlap. I'm staying here.
Because you're the technical guy. You really like the software developers. Let's face it, I mean, this is the town... This is the event where all the real tech guys go,
No,
right?
It's an overlap. PAX East starts before GDC ends, so it's very difficult. And you can only do what I'm actually feeling bad about is I'm away. The team is currently working on getting everything right in the beta of Wings, which is live as we speak.
Yeah, it's live as we speak and has bugs which I found, and I will.
Oh, don't.
Yeah.
That's why it's a beta.
I know it's why it's a beta, and we will have a lot of fun, right?
Yeah.
I really like the look of the Vulture, by the way, and the Furulence really brings back.
Oh, I know.
I know. Like this, I'm a romantic.
I like the brutality of the Vulture.
Oh yes. I like the really big gun on the Furulence, by the way, right? The big gun.
I think everyone likes big guns.
Yes. I don't know if I can afford it just yet. I'm gonna have to work hard on that one.
You can, didn't we make it 100 credits?
Right now, but
In the beta?
In the beta, yes.
Oh yeah, it's going to be expensive.
I'm sure it will. Yes, you're gonna work hard for that. But anyway, we're talking about comets and their.
We are.
Yeah,
and it's how do we come at these figures? And I think the thing backing off from it, the thing that's fascinating though, is it's a big problem.
yes.
You know, we're talking about whether it's really bad or really, really bad. But the problem is that it's bad. And I think that we're so, you know, on Earth, we're glorified staring at our navels, arguing about things.
Right.
This is quite important.
Well,
We need a contingency plan.
Here's the thing about the asteroid issue, right? Is we can imagine, as science fiction fans, we can imagine all sorts of horrific scenarios which would wipe out the whole human race. The killer asteroid thing is the one that we can predict ahead of time.
Yeah.
And we can envisage with our, ape-like minds how to stop it happening.
Yeah.
The dinosaurs, they couldn't figure that out. They couldn't figure it was going to happen, and they certainly couldn't figure out a way to stop it. So the killer asteroid issue represents like a transformation of life on this planet. The first time life on this planet is aware of a cosmological hazard.
Yeah.
And we can do something about it. And it's kind of like, it is now our failure if we don't do something about it, right?
I quite agree with that. There is another point as well. I think we have been incredibly lucky. We have had a very, very stable period of at least 20 million years when there haven't been any really major impacts.
Yeah.
That we know of.
We've had a few.
Oh, no, but they're tiny. They will have killed a small number. It wouldn't have been an extinction event.
Yeah, it would not an extinction level event.
And it's a bit like, we have all sorts of really bad catastrophes on Earth where there are big pile-ups on motorways.
Yeah,
but they're not
tsunamis
extinction. So we're not talking about, there will still be things that kill small.
I mean, that's the thing. I got to point, all these natural disasters, earthquakes, volcanoes, none of these have the potential to wipe out the entire human race.
Yeah.
So it's
most don't.
A lot of volcanoes could really mess things up, right?
Yeah, I mean the whole super volcano events thing, they can be threatening.
Yes.
But you are
couldn't do anything about those.
No. But I think that this is the thing. It would be great to be able to. It's a transition. One of the things that worries me is the galaxy is huge. Stupid number, between 300 and 400 billion stars.
And I have to say, you're storing the person who's discovering each of those stars. Do you worry you're going to run out of disk space? On a game-related note, by the way. Because 100 billion
I worry
stars,
about lots of things, that's the least of it.
Right, okay. Moore's Law is helping you here, right?
It is.
Yes.
And also, we're every minute, I think is it 12 star systems are discovered?
In the game?
Yeah.
Okay,
but
wow.
It's 0.0001%?
Okay, yes.
It's big.
People are hard at work, but...
And that's just visiting the system.
Yes.
It's a bit like saying, just because I've flown over the US, I've discovered it.
Yes, of course.
And there are different levels that will come. We've said, we're going to do in the future. I mean, we're getting off topic here. But we said, we will visit planet surfaces and all that. So there will also be a first person for that.
Yes.
Anyway, to come back to this threat thing, which it's our responsibility, really. My guess is most live life. I guess life is very common in the galaxy. But if you look at the Earth, it's taken such a long time to get to the position we're in. If you were to sample the Earth randomly, it would
just
mostly
be goop.
Either goop, if you're very lucky, dinosaurs.
Right.
Even they are right at the
very
end.
lucky. Right. Yeah.
But it took a long time for us to go from goop to dinosaurs. And then we are such a sliver at the end that it's quite possible. If you were an alien just randomly looking at the Earth, you'd say, oh, that's quite nice, green goop.
Green
it's
goop.
tasty.
Yes.
But and that may well be, and that's why in Elite Dangerous we have the planet. I mean, there are quite a lot of planets with life there.
Yeah.
But it's still little more than green goop.
Yeah, there's nothing that's very intelligent life isn't officially in the universe
And
other than
my
us.
guess is it's very easy for intelligent life, even life as intelligent as the dinosaurs, to get knocked back to the goop stage.
Yeah.
There have been events in the history of the Earth that may well have even boiled all the oceans. Really dramatic
Right, I
events.
mean, like 100-kilometer impact will literally boil the oceans away and kill all life. 100 kilometers, and that's not that big.
Tiny.
Yes, there are quite a few 100-kilometer comets out there, right?
And if you just think how many, even the ones we've seen, there are a lot of those, just one of those, and we're screwed.
Yeah.
Therefore, compared to the effort we spend fighting with ourselves, it would be great if we
Yes.
at least thought about a contingency plan, because as you were saying earlier, it's very likely we'll get warning, but not a lot of warning. We might get months.
We can envisage the technology now that we could catalog everything that is of significant danger.
But only the gravitationally bound stuff.
That's true. Well, I mean, even then, that is something we're not even cataloging right now. And I've got to say, that's what Sentinel is really wanting to do. So
And it's a great first step.
I'm pitching Sentinel Project here because those guys are awesome. If you want to hang out with those guys,
Absolutely,
I'll arrange it sometime.